Yes, I think we are live. Hey guys, welcome to this LinkedIn live session. I'm your host Pawan, and today we will be talking about building agentic RAG systems. And today's guest is a software engineer turned marketer. I always love reading his articles and posts on AI, agents, RAG, and much more. He is none other than Madhukar Kumar. Madhukar is a software engineer turned marketer, and is also the chief Gen AI evangelist, influencer, currently heading the marketing at SingleStore, a real-time database company. Madhukar has led product-led growth, PLG strategy, and implementation at several technology companies aimed at developers and technical audiences like Redis, Nutanix, and DevRev, to name a few. Welcome to this LinkedIn Live, Madhukar.
Hi, Pawan. Great to be here. And yeah, thanks for that intro.
Cool. RAG is all the buzz these days, and along with agents, the RAG approach gets a little more advanced. So today, Madhukar will help us understand more about RAG, agentic RAG, and agentic RAG in particular. Madhukar, can you throw some light on what RAG exactly is and why everyone is talking about it today?
Yeah, and then at some point, I might switch to some diagrams and some code
Yeah.
and even the demo or the example that I've built out, which, by the way, is on the GitRep repo. So anybody could just go download and start off with it. So for those who are not or new to RAG, which is retrieval augmented generation, basically think of it as large language models at a point are frozen in time in the data that they have been trained on, right? Now, of course, in the last few months, these large language models also have function calling, specifically the one that OpenAI released yesterday, that can talk to the internet and then bring back the data as well. So in a way, that is kind of RAG. But for large enterprises, if I'm a very large company, I might have 10 petabytes of data. Now, I might have multiple large language models and I have multiple AI applications, but I want to be able to answer the queries or do certain things with agents. But I want the large language models to be aware of my 10 petabytes of data. And that data might be sitting in SQL, it might be sitting in JSON, it might be sitting in data lakes, it might be also unstructured. So in enterprises applications, when you search through that and provide a context to large language models, that is what is generally accepted as a retrieval augmented generation or a RAG pattern.
Yeah, that is one of the techniques to reduce the hallucinating behavior of LLMs. Is it?
Yeah, and I know you have written quite a lot about it as well, Pavan. So uh, that's right. So why do we do RAG, or why do companies should do RAG? Is of course because a you want specific information for the large language model which they may not know of, and we'll give another example. And so it also reduces hallucinations. That is true. So accuracy is a big thing. But let's take an example of Europa. Europa, Jupiter's moon. If you ask ChatGPT, it's going to tell you that it's Jupiter's moon and so on. But if I'm working in a company, let's say it's SingleStore, and now Europa is also a project for us. It's an engineering project. So if somebody within the organization is asking what is Europa, it shouldn't give me that answer from large language models knowledge, but from my knowledge or my company's knowledge, which is an entire project and who are involved in it and what are the goals and what are the timelines associated with it. So that's an example of why you would use RAG in a you know corporate
Hmm.
environment.
And what is your view about the long context window LLMs nowadays? Because people are comparing RAG with long context window LLMs.
Yeah,
Is
I've been thinking about it. So let's first explain to the audience what long context window is. So typically, what happens is when you send a query, the query where it started off was just a question or a paragraph of text that the user sends to the large language model. And through the APIs, it goes along with the prompt, that's the prompt, along with the system prompt. Now, typically, there is a set number of tokens that you can send. And over the last couple of years, now there are models that you can even send 1 million tokens. So you're basically sending an entire book of data to it. So now the question is, what if the context or the input that you're sending to large language model is your entire 10 petabytes of data? Let's just go crazy and say that happens. So the answer is not that if it's going to happen. Yes, of course, it would happen. But the question is that more efficient for you? Because that entire 10 petabytes of data, as we talked about earlier, is not just unstructured data, it's also structured data. And
Mm.
even if your context windows are extremely large, and even if it's on a local network, sending out 10 petabytes of data is just poor software engineering in many ways.
Mm.
So, in my mind, I think long context windows are good for certain use cases, but there's also another factor to consider, and this might get better. There's something called lost in the middle for the context. So, when you
Mhm.
send a very long context to a large language model, it tends to pick up the initial part and the end part, but the middle kind of gets lost. So, the
Okay.
longer your context window grows, the less accurate it becomes. Now, yes, the models will get better and you might get better accuracy with it, but still sending a very large blob of data every single time you're engaging with a large language model is just not going to be scalable. So I think, again, short answer is it might be useful for certain use cases, but not for all use cases.
Okay, cool. So now most of the folks are talking about AI agents. So can you explain what are these AI agents?
Yeah, absolutely. So, fun fact, my master's thesis was on something called agent oriented software engineering, or multi-agent software engineering, maze. And I did this project along with the thesis with Dr. Scott Deloach, who was my advisor. And then eventually it got published into a chapter of a book. And what that initially, and I'm not saying I created that the multi-agent thing has been around for about 15, 20 years. But taking a step back, it is an evolution of how we do software engineering. When people started writing code in C or even BASIC, which I remember that's how I started, you wrote that entire program into one single file. And then you would compile the file and then you would run it. Then people realized that as it became more complex, you wanted to break it down into modules. So, you start writing functions and different files and included them as modules. And then from that monolithic piece, we evolved into something like Java, which was object oriented programming. So you create these objects, you turn them into packages, you include those packages into your program, and now it's become more, modular, so to speak. Then further along that, what we were thinking about 20 years or so is what if these packages are autonomous in the sense in a package it's still embedded inside your code, but what if these are packages that are running on their own and each of them are engaging with each other through network protocol. And so that's what we called agent oriented software engineering, where you would have some sort of a API endpoint, and each one of these quote unquote agents are talking to each other. And each agent is responsible for doing certain tasks. So the project that I had written was primarily about in Microsoft Word, as you write, the agents would go search on Alta Vista, which was a search engine at that time,
Mhm.
Yahoo and Google, and then come back and tell you that, hey, here's the latest research. And surprise, surprise, now all of these new code editors already have that. So now with Gen AI, when we think about agent, it's the natural evolution of that philosophy of thinking. So think of it as a way where an agent is very much like a human and it consists of three things. It consists of intelligence, which is access to an LLM or a large language model. It consists, which could be optional, of a knowledge base. And that knowledge base could be both unstructured data and unstructured data, which gets cached and so on. And third is access to tools or access to APIs. So, with the combination of these three things, I could now have an agent for SEO. And the
Mm,
SEO has tools to now go in and talk to SEMrush or Ahref or to my website. So now the agent, with its main goal, can go and do certain things on its own. And when you combine multiple agents to do certain things, then it becomes a multi agent architecture.
mm,
And so today there are a bunch of different, at least in the last few months, a bunch of different frameworks, as you've also written about, that have come about, right? There is Langchain was one of the original ones where you could write your own agents. And then Llama Index can do it. There is Crew AI. There is Microsoft AutoGen.
okay.
Then there is, I was looking at a Python library. There's Pydantic agents that you can write.
Identity.
And so there are a bunch of now agent framework. But the one that I like quite a lot is OpenAI Swarm, and that's the example that I've built out, which I'm happy to show. But think of agents as quasi-human with these three qualities.
Okay. So with this, I have one question personally, like what happens to the software developer jobs with these AI agents? Since you said they are more like human, they mimic human brain kind of thing. They do all the tasks.
Yeah, and I think we are already seeing that. If you have been following Cursor or Windsurf or
Hmm.
Bolt.new or Lovable, these are all, or even Replit, for example, these are all agentic IDEs or new way of programming that basically helps people not only improve their code, but even using no code, just natural language prompts, you can build an entire micro SaaS applications. So from that perspective, I think that's also an evolution of software engineering where
Mhm.
we were specifically going in and telling the machine how to do certain things, like go do bubble sort and so on, to now telling the machine to go do certain things without telling it how to do certain things. And so today, the great software engineers would still be needed to go and say certain things how to do better, right? So for example, if I'm doing adding a new feature, there's certain best practices that I need to follow, which the agent may not be able to know. But I think over a period of time that might go away. But there are still certain things that you would need software engineers for, which is to understand the basics and tell the right thing to the agents to do. So I'll give you another completely different example. Andy, who's here with me, he and I, we do some photography, right? And he's a professional photographer and I'm a hobbyist. Now, if Andy gets access to an agent, to a photographer agent, he can produce 10x faster and better quality pictures than I can because he understands the mechanics of the camera, he understands the lenses,
Hmm.
he understands what's bokeh, he understands what's f2 versus 2.8 versus the zoom lens and so on. So software engineers still need to know that. Like you would still need to understand the basics of the building blocks, the deployment, the QA, the
Hmm.
all the other things that go into it. And I don't see that going away, at least in the near future, despite the agents getting really good.
Okay. So now I see that AI engineers and data scientists combining both agents and RAG, calling it kind of agentic RAG. Can you explain what exactly is agentic RAG?
Yeah, I think that's the topic for today, isn't it? So
Yeah.
what so think of it this way, like if you buy into this, that all enterprises or companies are still going to do some form of retrieval augmentation or RAG.
Mhm.
And there's a lot of schools of thoughts on some people saying it'll go away, everything will be inside of LLM. Let's just set that aside for a second and just say that, okay, let's assume that RAG is still a thing. Then there are certain enterprise advanced RAG strategies that you need to involve, right? So let me see if I can now bring up
Sure.
let's see if I can bring up and share my screen on something that I had presented at TechCrunch as well. So let me know when you see my screen.
Yeah,
And
yeah, I see that.
okay, so a couple of slides. One is that when you're doing the RAG in your existing enterprises, it needs to have four qualities. It needs to have speed because even if it's 10 petabytes, you cannot expect the retrieval of data to take 3 minutes or 5 minutes. Two, as you had mentioned earlier, it should be free of hallucination, so it should be accurate. And three, it would be at a massive scale. And then, of course, the last part is security. And security has different dimensions in terms of, you know, am I allowed to see that data that the LLM is now giving me? To what about PII? Am I seeing the right data or not? And so on, right? So, in order to do these four things, there are certain things that you have to do as part of RAG. And this is what I call as advanced RAG techniques. And so the first and foremost is input output validation. You don't want the corporate user to now start asking it to do inappropriate stuff. So you want to validate that input and maybe also enhance it while it's coming in for better output. And even the output that's going out, you need it to be maybe in a certain format or in a certain style because that's your company policies. You need to have guardrails in the sense you don't want the user or the LLM to accidentally give you certain things that's against the policies.
Mm,
You want caching, you want hybrid search, and hybrid search is the most important here because you don't have just unstructured data in your company, you also have structured data. You have JSON, you have SQL, and key value, and you have geospatial. So you would still need to do advanced queries, and you need to do a dot product and maybe a cosine similarity. Then once the results come back, you need to re-rank it to understand whether it's more accurate, less accurate, and that leads to evals. So this is the advanced RAG techniques. Now, typically, just in the evolution of software engineering, as we talked about, we were initially about 2 years or so ago when ChatGPT hit the world, we were doing this in a very modular way, right? And now with agents, what you want to be able to do is, in order to satisfy that speed, accuracy, and all that, you actually need to have a contextualization layer that goes across your entire company data sources and be able to curate, search that data for your large language model in a few milliseconds and then be able to give it back to the LLM. So this is what I call as putting it together as a new architecture for building enterprise AI applications. So on this right hand side, and this is kind of where SingleStore plays in, by the way, you have different data sources coming in. You also have vectors, and you have iceberg tables as well. And then you have functions, schedule jobs, APIs, data apps, and that is then engaging with your agents. Now, with the agents, as we talked about, what you could potentially now do is take each one of the advanced RAG steps that we do and break it into agents. So there is an agent to just do embedding. There is an agent just to do, search for documents. There's an
mhm,
agent that does research. And then maybe there's a supervisory agent, right? So that is what I call as a multi-agent RAG. Now, this is slightly different from agentic RAG, but let's stay with multi-agent RAG. So now I have multiple agents that's doing RAG for me. Now, the other problem that comes with it is if I have a supervisory agent or a supervisor agent that is managing these tasks, then the results for me are non-deterministic in the sense if I send a query, now the supervisor agent breaks it into chain of thoughts, creates the tasks, and gives it to the different agents. Now, the problem is every single time I do it, it might produce different results, right? So it's not what corporates or enterprises typically like or want or correct, right? So you need auditability, explainability, and all those other things. So a slightly different way of doing thing is what I call as a deterministic workflow to orchestrate your agent. So think of it as graph-based workflows, right? And this is where Langchain has LangGraph, and LangGraph allows you to create multiple agents, and then in those multiple agents, you have different LLMs that you might be using. Some may be small, some may be larger, some may be commercial, some might be open source. And then each one of these agents have different tools, but you orchestrate the overall workflow in a deterministic pattern so that the results are almost always predictable. And so this is what we call as a multi-agent RAG system, but in a workflow which is more controllable by the engineer or the developer on how it goes about doing it. So that's kind of long-winded answer to your question about what is multi-agent RAG systems.
Amazing, amazing. So, with all these advancements in RAG, can you tell us where are we heading with this agentic RAG systems and applications in 2025? What we can see the trends and how it's gonna go? Because we saw NAV RAG to advanced RAG to agentic RAG to multi-model RAG, and also what will be the future of with all this?
Yeah, I think it's incredibly hard to predict what is going to happen next, given that every day, not even weeks, there are some new things that we learn
Yeah.
and there's new things that's coming about. But in large enterprises, what I have seen on talking to them, there are a couple of things that's constant. One is, of course, that the most common use case is customer support or customer success or
Mhm.
service agents that are now equipped to first help humans within the organization. So, not all of the companies are directly going to talk directly to their customers. The first step is most companies are using them just to help their, as a co-pilot or a co-agent, help their existing, um, service agents or success reps. So in that, I do believe the service industry, the contact centers are massively going to get disrupted. All the providers for that are definitely going to add real-time APIs so that you
Mhm.
can talk to those agents, and there's going to be a lot of disruptions around that. Now, when it comes to RAG, there are or advanced RAG, there are some really good things that have happened. For example, a lot of the big data was initially locked in Hadoop and then into very large data warehouses or in data lakes or lake houses. Now, with the entire world moving towards iceberg tables as a standard and a catalog standard, that data is now open for AI to take advantage of. So I do feel there's going to be a few more providers maybe that will focus on being the query layer for that specific kind of data. What would still be missing is combining all of that with real time. And
Mhm.
so, why is real time important? Well, couple of things. One is if I took the service agent or the customer success use case, now imagine if you are a very large B2C company and you're selling phones and computers. Now, a phone just came out, and you now have an issue that somebody just opened a support ticket about, that the battery is dying really fast. Now, if there's a co-agent trying to help your customer support agent, there might be 5,000 other people who have opened the same ticket. Maybe the engineer just found out and did a patch upgrade to it. But if your co-agent is now helping your agent and they have old information, and in this case, the old information is few seconds old, or it could be a few minutes old, then that's not only not useful, but it's actually inaccurate and harmful. So real time becomes a real use case now.
Mm.
And so accuracy matters. And then the second thing is just, as more and more agents and AI get closer to what used to be HCI, or human computer interaction, to human agent interaction, you would expect from a user experience perspective the way we talk to other humans, which is a few milliseconds response time. And most of the large language models are already doing that, like with the OpenAI and Claude and so on. You can now get millisecond response time. So if your data is not being curated and answered in a few milliseconds, that's going to be the last mile problem. So I do feel companies like SingleStore and other companies like that, where you can curate all of that data in a few milliseconds across petabytes of data, becomes really important for all enterprise AI application. But of course, I work for SingleStore, so I'm biased, but that's what I think will happen.
Cool. Yeah. So, can you now the audience understood what is RAG, agentic RAG, how AI agents work. Can you show us a practical tutorial or a demo so that since it's a hands-on, I hope everybody just signed up to get that link I shared, single store link. If not, go to the post that I shared. You can still sign up, go to singlestore.com, sign up, so that now I think Madhukar will show how his famous Mars, what he calls multi-agent rack systems, how it basically works, right?
Yeah, absolutely. So just to confirm, Pavan, can you see my diagram screen?
Yeah, I can see that. I
Okay.
can see.
So I'll try to make it as simple as possible. Then we'll go through the code, and then I will show how it works and how anybody can just download it, maybe
Cool.
even enhance it. It's open source, so you can just go and work on it and put in more features, which will be great for the community as well. So very simple use case. Let's say I want to build a multi-agent RAG system. And so what I want to do is I have an application, and anytime the user asks me certain things, I want it to get accurate information. I want to, all the things that we talked about. So one of the things that is great and has evolved, and I've been following for the last couple of years, is this package called Guardrail. And it has evolved into being called Nemo Guardrail. It's open source, and now it's actually backed by NVIDIA. So it's NVIDIA Nemo Guardrail. And what's even better is that now Nemo Guardrail has turned into an entire microservice, not just a library. So you can install Nemo Guardrail and it will do a bunch of different things for you. For example, input output validation, it will make sure that there's no inappropriate stuff. And you can define some heuristics and examples of what to respond and what not to respond. Then on the other end, I have a single store tool, which basically goes into single store and gets back recommendation for movies, but it does all in a single shot SQL. So the SQL has been defined by developer, that's me. And that one single SQL query doesn't go to a different vector database to do a dot product, doesn't go to JSON. In one query, it says, give me all the recommendations based on a semantic search, order it, rank it, and then sort it only by this specific user's favorites, and then return this by ranked version, and then it sends it back to the Swarm agent. So I'm using OpenAI Swarm agent. And the thing with what I like about Swarm, OpenAI Swarm agent is, or Swarm framework, is it's very simple. You just define an agent, you give it some attributes, and you give it the function. In this case, the function is the tool to run the query against single store. And then the Nemo guardrail here actually serves even as a router for me. And you can choose not to do that, by the way. This is just one example of doing it. So the Nemo guardrail would be when a query comes in, I always ask Nemo guardrail to say, hey, is this a valid input? And if it is, what should I do? So it'll come back and say, this is not the right input. So go back and say, I cannot respond to it. Or you would say, no, actually, this is the right one, and you should call single store agent. And so it calls the single store agent and then returns it. So if you were to see, let's say, more of a sequence diagram, let me see if I can make this a little bit bigger. It is exactly like I just said. So the user comes in, enters the query, it goes to Nemo guardrails, and I'll explain what Rails is, gets back the response, and then if it's needed, it either goes to the Swarm agent and runs the SQL against SingleStore. Once it gets the data back, that is RAG, it then sends it back to OpenAI, and then OpenAI basically responds. Now, just like I mentioned, if you were not using SingleStore, this would require you to have VV8, Milvus, Pinecone, Mongo, MySQL, Postgres, any number of those. So you would add latency there. So this is where I like this idea of just a zero shot SQL query, and I'll show that. This could go to multiple different LLMs as well. So you can actually configure here to say for certain queries, go to this agent. That agent is talking to OpenAI, and the other one is talking to maybe Quen 2.5, which is a really good open source model. And the third one could be talking to Anthropic because it returns code. So, what does the program look like? And tell me if I need to make this bigger or if this is good.
A
Pawan?
little bigger.
Okay. So let me see if I can do this. How about now?
Yeah, this should be fine. Yeah.
Okay. So this is the main flow here or the main file, and I have added a UI to it. If you listen to my last LinkedIn, that was a command-based tool, and this morning I quote unquote upgraded it and I committed it to my repo. So it now has a UI, and I'll show you the UI as well. So this is importing Swarm, and Swarm has something called an agent. This is the single store library, which has been optimized for really high performance queries, but it is MySQL wire protocol compatible. And then there is Nemo guardrails, as well as it is Rails config, which again I'll show in a second. Then there is a .env file, and the env file basically has all my secrets, so OpenAI key as well as single store connections. So I initialize the client, I initialize the config. You can ignore this for now. It is a caching thing that I implemented this morning just to make it a little bit faster, so that if you're asking the same queries, then it basically responds from the cache versus going to the database as well as your LLM all the time. And then this is a function to get the guardrails response. This is to get the connection, which is used by searching movies. And here's the query. So I'm not relying on LLM to generate SQL for me because I still don't feel it's accurate, specifically against certain dialects. So in this case, I have this query and I have told the agent that, hey, if you find anything that's related to movies or getting recommendations, make sure you run this. Now, in this
Hmm.
naive example, there's no dot product, but you could essentially go run dot product as well as group by aggregate function, everything in one single query. And that's a separate LinkedIn Live for that. And so now this is the single store query. It gets the response back and try and catch. And then what we do is we finally create the agent and we run it first by asking Nemo guardrails. And once it gets back, then I get it to basically respond. So, what does the overall application look like? So, I've just run it. And now, if I go to,
By the way, we have shared this repo link in my post. If you guys can still go and try this out.
so when you run the application, now this is what it looks like. So, let me just start from scratch. And this is just a simple UI which runs on UVcorn and it uses Fast API to talk to the backend that we just talked about. So first things first, I'm going to ask, hey, give me some French movie recommendations. And so if I show you what's happening in the back end, or at least in the console, it's saying go to Nemo guardrails, and Nemo guardrails, then it's going to respond. And depending on the Nemo guardrails respond, it's going to then go call the single store agent through Swarm. And then from Swarm, it will go back and send it back to OpenAI and then get the response back. So as you can see, now it has given me the response. But let's say I ask it something that as a company, I have a rule against. I don't want people to get involved into politics. So if some user says, tell me what do you think about the current government? And when I respond, it immediately responds saying, I apologize, but I cannot provide advice on that topic. And if I look at this thing over here in the backend trace, in the first one, it says, I'll go search for the movie database and returns. But in the second one, it says that this is not the right response. And so it returns from the cache response saying that I'm not allowed to answer it. So let's look at now Nemo guardrails. So Nemo guardrails has this thing called two things. One is the configuration. So you basically say, I want you to use this engine and this model. So I'm using GPT-4o and OpenAI. And then there's a bunch of heuristics or rules that I've given the overall Nemo guardrail. So it says if these are the kinds of questions or queries that you get from the user, then let's define certain things. This is the greeting. And what is that flow? If the user then uses this kind of expression, then you are going to respond with these kinds of answers, right? So you can do both positive and negative. And so what I did was I created these things, which is specific to SingleStore. So if you ask for, can you recommend some movies? What movies should I watch? Suggest movies like this. Then these are the kind of things that you should respond to. And then this is the flow that it should be. The user asks, you inform, and then you delegate it to the agent. So it's almost like a quasi domain specific language that you can build. And in fact, I am using Windsurf here, which is an AI agent based IDE, and I love it. So you can even ask it to help you with creation of these rules, and you can put traces to see if it's working or not. And then similarly, if you notice, I have these off topic queries. So I could say, what do you think about the government? Which party should I vote for? Who should I vote for? What's your political opinion? If those are the kind of questions, these are the kind of answers. And here's the flow. If user asks about the politics, you refuse to respond. And so that's it. It's as simple as that. I will show you where the repo is. So if you go to, and I'll put it on the single store repo as well, but you go to my repo and say agentic RAG. This is the overall repo. You just do git clone. You create a virtual environment and requirements.file. There's certain things that are required to install. You install that, and then this is the command to run it. So uvicorn app reload, and then you can so you can see what the code flow is, and then you can take it further. You can add more configurations in Nemo, or you can also add additional files and additional agents that can be called either through Nemo or it could be called directly from your application. So that's the overall flow.
Amazing, amazing. Uh, I think people are going to try this out and see for themselves how multi-agent rack systems work. Um, yeah, we have come to the end of this session. It was really amazing talking to you, Madhukar. I think let's see if we have some questions if we can take, right?
Sure. Yeah.
Yeah. My friend Deepak Roy is asking, is it functional promotes OpenAI prompts? He's saying it's prompts. Is it functional prompts OpenAI? I didn't quite. get it what he's asking.
Yeah, I'm not sure. So
Yeah,
functional.
but somebody responded back to Deepak Roy with this.
Yeah, it says new tools for developers. Yeah, so I think they are referring to the announcement from OpenAI yesterday, which
Okay.
basically announced access to the O1 series of model through APIs and real time. And that's going to be my next post, by the way, that you can now, with WebRTC, you can literally create web pages with this APIs, and you can talk to it and it can change the web page on the fly. So you can say, hey, change the background
Hmm.
color or show me something different. So now we are finally at a point where the user decides what to see on their web page versus, from the
Okay.
marketing world, just building customization for a batch of people.
Thanks, Chaitali. And I think she also has a question. To make multi-agent RAG systems more deterministic so that the supervisor agent can guide the sub-agents better, what would be the best approach?
Yeah, so there are, remember I mentioned there are two things that have evolved in the multi-agent network, multi-agent world. One is, of course, the orchestration. So the orchestration is either you create a supervisory agent and let it decide through chain of thoughts what it's going to do along with other agents. And then the second one is what we talked about, where you create a graph or a workflow and then you decide what is the next step. And so the answer is always checked and deterministic. Now, there's something that has happened more recently, and it's an interesting space, is both, and by the way, AWS Bedrock also has its own guardrail and it also has its own orchestration as well. So that's, I haven't tried that, but I've heard that it's also pretty good. But what has happened in the former way of doing things is Microsoft and a few others have now introduced what is called a super agent. And the super agent creates other agents on the fly based on the overall goal and the request. It's still not deterministic, but I've heard from different developers that it's really, really good. And I think that's kind of where the IDEs, the agent based IDEs, are going towards. If I were doing this for an enterprise, I would still go with a graph based approach because I think even in longer term, that's a much safer and much more controllable way of managing the agents.
Cool. And she also has one more question like, how do we tackle the new security challenges posed by multi-agent RAG systems?
Yeah, security, I think it's a wide term. I think one of the things is what I would say governance, right? Governance in the sense, if I have a multi-agent system and the multi-agent system or RAG system or Mars, and it's talking to a bunch of different databases, but the user is not authorized to know about that data. So that's where you can also add governance policies within something like a Nemo guardrail. And you can also embed or create a brand new agent that uses RBAC. And then you can create another agent that does auditability or even explainability, like it should explain why this answer was given. And that goes back into the same database where you can then take that with a human in the loop and then refine tune or retrain or fine tune your existing models to get better over time.
Okay, so last question. Any thoughts about Langchain and Langra for these kind of use cases, or should we use the approach of importing individual packages and work with it?
I think it's totally up to the developer and the organization. I like LangChain. I like LangGraph. It also has a LangGraph Studio that allows you to visualize and then also, debug while the entire flow is happening. So it's a really good feature. I like the simplicity of OpenAI Swarm, even though it is, they call it as a, experimental feature, because for things that I'm trying, it's extremely simple. But Crew AI is also good, and you can also use AutoGen from Microsoft.
Mhm.
That is also gotten a lot better. So it's really up to the user on what you think is the right choice for your programming skills.
Cool. I think that's it for today. Thanks for joining, Madhukar. I think where people can contact you. You are. I saw your recent TechCrunch video on this, and it went like I think more than 30K views is what I saw.
Yeah, we are with AWS. We are also building out that reference architecture, so people would be able to just go and download a cloud formation script and maybe get started with their own customer success copilot as well. But yeah, if people want to get in touch, I'm on LinkedIn. I'm also on X or Twitter, as well as Blue Sky. So happy to connect with
Okay.
you.
Cool. Thanks for joining as a guest for today's live LinkedIn Live. And yeah, we can do more of this. I see a lot of interest with these kind of hands-on. Thanks for joining.
All right. Thanks, Pavan. Talk to you soon.
Thanks, guys. Thanks. Bye-bye. Bye.